Hello and welcome back to the channel. Thanks for taking an interest in this continuing project. This is part 3 of my DIY home flight simulator build. Currently, I'm in the design phase and getting closer to the final design. Along with concept and design work, I have also been obtaining electronic components and mechanical parts for this build. The design is slowly progressing and coming into focus. So just to recap, this new flight simulator will meet some specific requirements. Number 1, keep me current with flying and instrument procedures. Even though this is not an FAA approved flight training device, I will still use it to keep my instrument procedures and skills sharp by augmenting my self-training practices before any flight reviews or currency checks. Number 2, my goal is still very clear. I will provide a full set of plans for this home simulator free to anyone interested in building a home sim pit. The main structural plans will be the first release. They should be available for download sometime during the first quarter of 2022. Electronic schematics and additional components will follow after. Number 3, this simulator is designed to be disassembled. I want to be able to disassemble and reassemble the full simulator easily. This will be required if it must be relocated or moved. Number 4, it is highly desirable for me to be able to source the majority of parts from local hardware and electronics outlets. Number 5, for pure enjoyment and entertainment of having a full-size immersive home flight simulator. I mean, let's face it, this may be the primary reason, just to have fun. Now let's take a look at the simulator in its current design state. The overall size of this DIY home flight simulator is 5 foot 8 inches long, 3 feet 9 inches wide, and 5 foot 0 inches tall, which that should give you roughly about 4 foot 9 inches clear interior height. The main forward-facing monitor will be an 80-inch TV. It will increase the width required to house the entire flight simulator. The 2 side view windows are built around two 42-inch TVs. More information about the exterior visuals in a future video. The floor framing consists of 1.5 by 1.5 Alexandria molding. This is a standard lumber size similar to a 2x4, but it's half the size and weight. The floor members are connected together with metal angle clips. Metal Simpson strong tie angles are 1.5 inches by 2 inches by 1 3/8 inches and are available at most local hardware stores. They are used to join the structural floor members and will also allow for quick disassembly if required. The floor decking is cut from 3/4 inch plywood or MDF board. It will have screws fastened about every 12 inches along all structural members below it. The floor decking can be painted or covered with a short interior carpet. Anyone building this will be able to customize it to their own specifications. Please note that the colors in the 3D model are not finished colors. They are just there to differentiate the different components that make up the simulator, and they do not reflect the finished colors. You will notice a cutout section near the front of the flight deck. This cutout is to allow for placement of the Redbird RD1 alloy pedals. The floor deck cutout allows the pedal base to sit lower and keep the pedals in a more natural ergonomic location. Hopefully this will keep the pilot's knees from interfering with the yoke or the lower portions of the panel. The cutout can be moved or sized per the builder's requirements. The pedals you choose will drive your specific dimensions. The dimensions that I have provided should accommodate any average size pilot if you intend to use the Redbird RD1 pedals. One other note worth mentioning, I will provide an alternate to the plan that will include a floor platform without the pedal unit cut out. This will give the builder the options to use any USB pedals of their choice. This floor framing structure will provide a solid, stable platform to build upon, and it can be disassembled if needed. The main framing is simple post and beam construction that consists of 1.5 inch by 1.5 inch Alexandria molding members cut to length and attached using more metal Simpson strong tie angles. The tie angles are 1.5 inch by 2 inches by 1 3/8 inches, and they're typical throughout. There are 4 locations where the Simpson angles will require bending to a specific angle other than 90 degrees. The specific angle will be provided in the plans. When building, the framing structure may appear weak or unstable. This is only temporary until the exterior sheeting and the desktop with panel are installed. The roof section will be built up with 1.5 inch by 1.5 inch Alexandria molding. Additionally, there will be 1/4 inch MDF ribs with curved arcs that will create a nice curved ceiling inside the flight deck. The 1/4 inch ribs will attach to the 1.5 inch members with 2 small angle clips and screws. This is a simple connection that can be removed if the builder needs to disassemble the simulator. I will also provide an option for a flat, non-curved ceiling in the plans. Now let's look at what I call the heart of the simulator framing, the desktop and the panel. The desktop, denoted in light green, is 3/4 inch MDF or plywood that is bolted to the top of the 1.5 inch by 1.5 inch framing members, and it sits at the front of the aircraft. This plywood base will support the 1/2 inch thick MDF built-up sections that support the panel face and the instrument panel monitor. The components are shown with access holes in locations that will allow wiring to pass through. The builder can choose to add the holes to any location or may choose not to have any access holes. The framing will support a 1/2 inch thick back panel, shown in orange, and a 1/4 inch thick finished panel front. The instruments are displayed on a monitor that is mounted to the back panel face. Angles are attached around the instrument monitor to keep it in place and are adjustable to accommodate various size monitors. The curved glare shield is a non-structural piece, meaning it will not provide any support to the structure. It's built up from 1/4 inch bendable foam or lightweight material. It will be covered in vinyl or another soft material to give the panel a finished appearance. I will provide more specifications later in the final plans. Now let's look at the finished panel front face. Holes in the panel front face will allow gauges to be visible to the pilot. The instrument faces will be rendered by a secondary computer or Raspberry Pi running AirManager software. Rotary encoders and push buttons will be inserted into the panel and allow the pilot to interact with the simulator. Small shallow grooves will be cut into the panel's back face, allowing wiring connecting to the buttons and encoders to be traced back to the BBI32 interface board. A switch bank is located at the lower left side of the panel. Single pole double throw SPDT toggle switches will be wired back to the BBI32 button box board. A keyed 5-position rotary switch for magnetos and starter will also be located near split master rocker switches and the avionics bus switches. The Redbird yoke and throttle quadrant have specific dimensions that drive the locations of the panel supports located behind the panel. Each builder may choose a different set of controllers. I have specifically designed my system around Redbird because I like the hardware. If you build this with other controllers, you may need to adjust the framing accordingly. The yoke sits on 2 1.5 inch by 1 1/8 high wood rails. The USB controls will be locked into place with small screws and angles not shown on the model at this time. Located below the Redbird yoke controller is the parking brake handle and support components. I have purchased an actual used Cessna 172 parking brake handle from eBay for $40 and currently working on the design to integrate it in a realistic manner. I will provide drawings and component build-up plans, but more on that later. Located slightly off-center right and below the Redbird throttle quadrant is the console. The console is built up from 1/4-inch MDF board sections assembled and attached to the bottom of the desktop below the panel. It will provide an additional vertical support to the main desktop and will house some additional flight controls such as the trim wheel, the fuel selector switch, and the fuel cutoff switch. I may use some flat aluminum panels to create the facing for the console, but have not designed anything specific at this time. More design changes will come. Located next to the flight instruments and the monitor is the radio stack. There are several companies that make NavCom and GPS units for flight simulators. Some of them are very realistic, so currently I have only provided the radio stack cut out. The actual radios, GPS, and transponder units will be installed later, and more information will come in another video. Just to the right of the radio stack will be a RAM mount screwed to the finished panel. This RAM mount will hold my iPad running ForeFlight. The builder can choose to put anything in this area. Some may consider installing another monitor, driving more instruments, or glass panel components. The options are virtually endless. Located just below the iPad will be another small bank of toggle switches and push buttons. Here's where I will put controls for non-simulator events. An example would be cabin LED lighting, switches to run fans allowing ventilation in the cockpit, or buttons to change views in the simulator, possibly even a pause button for the simulation, but more on that later. Let's look at the exterior of the simulator. The sides will be covered with 5/8-inch MDF board with 1.5 by 1.5 rail members attached with screws. These will act as a shelf to hold the window monitors. Small metal plates and screws will secure the side window monitors. The MDF board will also be mounted above the monitor at the top of the frame to provide additional support. The roof will close off the top of the flight deck. It will be 1/4-inch MDF sheets attached with screws to the framing members. This provides a large stable platform for projectors if the builder decides to use projection systems to produce the external images on a curved screen. I will eventually provide a curved screen option in the final set of plans. Now it's time to look at the interior sheeting. The sides and ceiling are created using Coroplast. Coroplast is similar to cardboard, but it's a corrugated plastic material that is commonly used to create signage. It's about 1/8 of an inch thick and is easy to work with. The colors represented in this 3D model do not reflect the true finish colors. The colors are only there to differentiate between the different materials of the model. At the base, the Coroplast is curved to create the rounded fuselage shape as seen from the interior. It runs up vertically the entire wall in 2 sections. The window trims will be created out of Coroplast or a thin light wood just to give more dimension to the window openings. Behind the Coroplast, in between the framing members, will be 1.5 inch thick rigid foam insulation. This will provide thickness to the walls at the window openings. The builder can customize the interior by gluing vinyl or fabric to the Coroplast interior panels. Stainless steel screws can be used with washers, and that can also be used to finish the interior to make it more realistic. The ceiling will also use Coroplast and will curve along the bottom sides of the ceiling ribs. The builder may choose an option to build the ceiling flat without the curve. The visors are built up with lightweight 1/8 inch thick or less plastic sheets found at a local hardware store or craft shop. The framing is simple wood or metal attached to the main framing. A list of parts and construction diagrams will be included in the final set of plans. The actual design is still a work in progress. The additional interior trim pieces will be noted in the final plans. They are not shown in the model at this time. They will likely be cut from Coroplast and wrapped in vinyl. Other assorted interior details, such as window and door levers, straps, placards, will all be added for additional realism to help create an immersive experience for the pilot. I will cover the TVs, monitors, and electronics in another upcoming video. So that's the current state of the simulator. I am still moving forward with the development of the plans and construction documents. I hope you found this interesting and informative. Thanks again for supporting the channel by viewing this video. Merry Christmas and have a Happy New Year. Fly safe.